Hello, ladies and gentlemen. My name is James Wenzel. I'm just going to ask you guys about if you want to hear a joke to help them modulate the volume. Is that cool? Networking joke. I promise it's clean. Did you guys hear about the UDP joke? You'll get it eventually. OK, my name is James Wenzel. I have a gravelly voice, not because I was partying, but the dry air is really getting to me. So if you can't hear me or understand me, please let me know. I'm a solutions architect, networking specialist in the partner org for AWS. And you guys are in luck. I have Harvo Jones, who is a principal software developing engineer, who is one of the key people that actually created this service that we're going to talk about today. So let's get into it. How many of you have used Global Accelerator before? Or had any experience or read up on it? OK, a few of you. OK, cool. So this is what we're going to go over today. We're going to go on building with it, how to use it, where it's positioned, and then Harvo is going to go over what's inside, how it's durable, how it's scalable, and all the cool, fun stuff that he put into it today. OK, so a couple of key features. First, it's a single point of entry. This Global Accelerator puts out Anycast IP addresses, single IP address, or double, because it is redundant, out on the internet for your customers to attach and communicate to your workloads all over the globe. Same IP address. The second thing that it does is it intelligently helps route the customers to the AWS Backbone. And that's important because the closer we can get your customers onto the Backbone, then our Backbone will carry that traffic to your workload. And our Backbone is a private network. It is large. We'll talk about it a little bit. We can also set different targets for where the accelerator sends these packets after somebody attaches to the Anycast IP address. They can be IP addresses. They can be EC2 instances. They can be our elastic load balancers. And then lastly, we can also talk about a little bit on how this is going to accelerate your workloads and how it's different going over the AWS Backbone and getting on that Backbone with this service as fast as possible versus having your packets and having your customers go over the general internet to get to your workloads. So if you've done any or gone and seen or gone online in any of the AWS networking tracks, you'll probably be familiar with this slide. So what we're going to do is we're going to remove the pieces that we don't need, and we're going to basically set up our workload, something that's common, that isn't too unique for anybody else, so that we can talk about how Global Accelerator can help. So here we have our front end, right? We attach our internet. We have our label. We'll have our DB layer, right? We'll add our API layer, and then possibly a transit gateway in there with these different VPCs, right? And then the packets start talking. Everyone is happy. And then we add our on-prem, right, so that we can actually get to our workloads. And then in this slide, I want to point out one thing about Global Accelerator and any other type of networking constructs or networking services that you may use. It's very important to understand that when you're working out of a VPC, no matter what you're connected to, its local routing table is always king or queen, right? So any changes that you make here, you can even circumvent any other type of routing. So it's important to understand your routing technology. And of course, the second piece is your associations and your transit gateway routing table, right? So we want to make sure that this is well architected, everyone's happy, and it's going great, and then we can go ahead and try to take it global. So we open it up to the world. We're launched in US East 1. We can say, OK, we're ready for business. We get a customer who shows up, starts talking to it within North America. Everybody's happy, right? So because we're on the internet and because your offerings and your applications are so well received, everybody else wants to get access to it as well. So they go ahead and they start communicating. But there's an issue. Not everything is the same, obviously. If we have somebody coming from APAC and going to your workload in North America, you're going to have some problems. You're going to suffer what we like to call internet weather. So what's a good example of internet weather? How do we explain this? Well, you have your workload, and you have the internet and your user, and we would hope that you can go ahead and just communicate easily. But that's not always the case. There's many hops that you can go. The internet can even change its pathing while you're communicating. So when your customer goes ahead and makes a request to talk to your workload, the return traffic may not be the same. So, of course, this is going to cause some issues, latencies. There could be problems along the way, rerouting. And these are things that we always like to say we can't control, right? If you have an application, it's a little slow. How many times do you have people come to you saying, can you make it faster? And really, when you've deduced it and troubleshot everything you could, it comes down to, it's the internet. There's not much I can do about it. Well, we can do something about it now. There's a couple of things that we already have that could handle this as well, or help us route around this, maybe not quite as efficiently, such as Route 53. How many of you have used Route 53? Familiar? Good, good, good. So, with the advanced features, geolocation, if you distribute your workloads around the world, you can tell Route 53 to send it to the closest region. You're still going over the internet, though. The other thing you can do is you can set up your failovers, right? If something goes down with your health checks, and then switch over to another workload in another region, maybe even the same region, you still have the internet issue. You also have the issue that if something does go down, relying only on Route 53, that IP address could be cached in your customer's browsers. So even though you make a change, or even though that the TLS might be small and they switch over, there's still that possibility that their experience with your application may be impacted, right? They might have to refresh their browser, they might have to go into incognito mode, something, flush their cache. The other option that we have is CloudFront. Right? And CloudFront can be used, obviously, in conjunction with Route 53 or any other DNS for vanity DNS names. FQDNs are fully qualified domain names. And it will also cache your content at the edge. It will also give you the opportunity to use Lambda at the edge. It's a good service. But unfortunately, it's only really good for HTTP and HTTPS type traffic, layer 7 top-level traffic, right? So it doesn't help us with the UDP traffic or any of the lower-level TCP traffic. And then lastly, we have our Global Accelerator. Global Accelerator lets you use TCP and UDP traffic. It does intelligent routing, and as I mentioned, it gets you onto an AWS Backbone as fast as you possibly can. It allows you to control weights and dials as to where you send your traffic to. You can do adds, moves, and changes with it without impacting your customers at all. They may not know. And it's pretty, it's a pretty good intelligent service. Otherwise, I wouldn't be standing here with Harpo. So what makes a good global accelerator? I mentioned before the backbone. Now, to talk a little bit about the AWS Backbone, you need to understand everything between regions, between the availability zones. All communications from AWS service to AWS service goes over AWS stuff, right? We have our own fiber that runs across the ocean floor. We monitor it and we check it. Every piece of that communication on that backbone is encrypted end to end. It's a dual, or a redundant, if you will, 100 gig network. At every point of this network, we can go ahead and reshape, route around traffic, detect brownouts. All of that traffic comes from our customers, and it comes from our customers' customers, and that's it. So we know what's going on. We can metric, you can look at it, we can log it. We have a good handle on this network, unlike the magic of the internet. And of course, 199 points of presence and counting, 69 availability zones. We've got 22 regions, and of course, we're going to bring on more. And we're going to keep bringing on more and more. And as we bring on more regions, as we bring on more POPs, as we bring on more things, AWS services, we're going to rely on our backbone. We're not going to rely on the internet. There will be edge services, but they will still be connected to our backbone. So I mentioned that our backbone gives us a sense of security. It's encrypted end-to-end. All the traffic, we know how to reroute and traverse it around, which gives us more reliable performance, right? So we can get ahead of things. We are the ones that actually will add capacity, so we know what the current capacity of our backbone is. If we know it's getting to the point where we need to add more, we'll have already had work orders in. We're already go ahead and making it larger. And then, of course, availability. We have the redundant 100 gig backbone. Something goes down, we can switch over in milliseconds to another line. And then lastly, we're connecting closer to our customers at our edge locations. We can have a point of presence all over the globe with our partners, Equinix, Verizon, all of those, where we actually house our equipment close as possible to where you are. So what does this look like? And remember our internet weather thing. Essentially what this does with our backbone and with Global Accelerator and with the intelligent routing that will take your customer's request and forward it to the correct region that you want to through your endpoints, which we'll show you how to do. We essentially move not the customer closer to AWS, but AWS closer to your customer. And then at that point, the only latencies you really have to worry about are the latencies between you and your ISP, your on-prem, and you can complain to us if you have issues on the backbone. So what we use as a point of entry, the knock on the door, if you will, is an Anycast IP address. So Anycast basically is a network addressing routing methodology where you advertise one address everywhere, and then you can route multiple paths, N plus endpoint destinations beyond that. So what does that mean? So It'll help us we get 2 IP addresses. We're always redundant. We try to eat our own dog food, so if we put a service out, it's going to have redundancy. With that redundancy, we'll be handing out 2 Anycast IP addresses. And with those 2 IP addresses, you don't have to tell your customers, okay, here's a CIDR block that I want you to whitelist because we might have some adds, moves, and changes. Or the more scary thing is you run out of that CIDR block and you have to add a new one and communicate to all of your customers. All you have to do is whitelist those IP addresses. And you can put both of those IP addresses into your Route 53, do a round robin, anything like that. It will also reduce your global address complexity. For each workload that you want to put a global accelerator in front of, you only have to advertise those IP addresses. In DNS, to your customers, as was mentioned for whitelisting, you don't have to manage or figure out which IP addresses are for where within a large CIDR block that you put out on the internet. The other thing that we can do, which is pretty cool, and it's pretty secure as well, is what we like to call source obfuscation. So the endpoints, EC2 instances, the elastic load balancers, IP addresses, they don't have to be on a public subnet. They can be private. So the only entrance publicly that's available for customers to go into your workloads is through the Anycast IP addresses that you advertise through the Global Accelerator. And of course, it gives you a global presence. So what does that look like now? So we have our workload that we have up and running. We've realized now that even though from around the world, we still want to distribute it so that there's more than one, maybe one on the one side of the globe, and then we'll put another workload on another side of the globe. And to route the traffic intelligently, we're going to put our Global Accelerator on top. So what does that look like? So first, we add our Global Accelerator. Each Global Accelerator has its edge location, or POP, right? And that edge location will have an IP address, the Anycast IP addresses. Remember, you get the option of 2. And it will be the same Anycast IP address in every location that your customers talk to, right? And then each of those addresses or those locations will be closest as possible to your customers' workloads within the region that you house. So when they start to communicate, all they do is go directly to your workload through our backbone. So they'll go ahead and get on their computer or on their mobile phone. They'll go to contact your workload. Then they will be rerouted to the closest POP to where they are, and then right onto AWS's backbone. And from there, we can control all the latencies, timings, and all that fun stuff. So how do you make this thing? It's really not that hard. All you do is go into the console. You can do a search for Global Accelerator, give it a name, go ahead and create the accelerator. Give it a name that's something kind of intelligent. Don't do what I do and just do demo accelerator over and over and over again in every region and then confuse yourself on a live demo. Actually give it an intelligent name that is actually relevant to your workloads. There are many companies that actually use multiple global accelerators for multiple things. And then we go ahead and we set up our listeners. And you can see here, I've got a couple type of listeners. I've got a UDP and a TCP listener. And then I can choose my source IP if I wanted my applications to remain stateful and if they require any type of affinity. I go ahead and I create my endpoint groups within my different regions. So remember, you can globally distribute your workloads. And you can even globally distribute your listeners. So if you wanted your UDP for whatever reason to be in one area and your TCP listeners to be in another area or separate those ports out, you can do that. And then you set your traffic dials. So traffic dials are a way for you to control the flow of traffic. And this traffic dial here basically controls how much traffic on a percent type basis of which region you want it to go to. Now, if you have everything set to 100, 100, it doesn't mean that you're doing an active configuration. It just means that both of them have the same opportunity to receive that traffic. And we'll get a little bit into traffic flowing in a little bit. And then, of course, you can configure your health checks. Now, one thing to note, when you're creating a global accelerator and your endpoint destination happens to be a load balancer, an ELB, the global accelerator will inherit its health checks. There's nothing you have to do, right? So if your local load balancer deems that something is not working, right, it will basically communicate up to the global accelerator and it will take it off of its routing path. If everything fails and your load balancer fails open, it will still communicate to the global accelerator, and the global accelerator says, you're failing open, I'm not sending any traffic to you. So we configure a health check that way inheritively through our load balancer. But what if we're using an IP address? What if we're using UDP? So are you guys familiar with setting up health checks with Route 53 and elastic load balancers? Yeah, nothing really different here, right? All this stuff is very familiar. The one thing I want to point out, though, is with UDP traffic, much like my joke earlier, it's a little hard to control. So our recommendation is create that one site page that says everything is okay. Create it on TCP and have your accelerator point to that. So whatever you do when you hit that page, have it go and do all of its checks, everything, and come up with a message that's consistent, everything is okay, set that up as your health check, and you should be good to go. Okay, so now we have our region endpoints. You can see the different things that we can choose, our network load balancer for our endpoints, IP addresses, EC2 instances. When you go ahead to create that, everything that's available will show up. Also, your ARNs will be available that you can show up to in your dropdown so that you're absolutely sure which resource you're taking advantage of. And then, of course, the weights will let you portion your traffic to each of the endpoints itself. What does that mean? Again, I'll show you a little bit later, but to cover it just briefly, you can control how much traffic on a percent basis to which region you want it to go to. On a weight portion, you can say which endpoint specifically gets more traffic. So you can really control the flow. And then we create our accelerator. Remember I told you get a set of 2 Anycast IP addresses because of our redundancy, which Harvo will go over later. And then you're good to go. You can hand those out. So let's talk a little bit about traffic control. Okay, so here we have our global accelerator, and we're going to do our optimal endpoint selection. Remember I told you that global accelerator figures out where your customers are coming in via the Anycast IP address to the AWS network to get to the closest workload you have within a region. To do that, we do an optimal regional selection with a 5-tuple hash algorithm, tuple being source, destination, protocol, port. And within this example, obviously, it's found the load balancers within the same region that it feels is the closest and the fastest routing that when your customer communicates with your application. So remember I talked about the dials. In this example right here, both dials, as I mentioned, 100%. Not active-active, just 100%. It's still doing that 5-tuple check to find out which packet should go where. It's not sending the same packets to all the regions, but it's helping route, and all regions have the capacity and the capability to receive that traffic. Why would you want to do something like this? Well, you might be bringing up a new region. You might be taking down a region. You might be doing some change that affects the entire region. So you want to basically route the traffic away or tell the global accelerator to route traffic away or reduce the amount of load of traffic to that region, and your customers will never see the wiser. As long as the capacity behind the ALB, or the global accelerator, can handle the traffic that you're going to send to it, your customers should never see a difference. So in this example, of course, we turn off. We have our change that's going on. We're bringing down the whole region. We're updating all of our EC2 instances or whatever it is that we're doing. Customers don't even know the difference. So remember I talked about the endpoint weights. Now this is more inside. And this is also going to help you with any type of micro changes. So if you're not going to take out the entire region and do an entire region refresh, maybe there's only a couple of targets that you want to do, right? Maybe there's a problem and you want to kind of see what's going on, so you're going to send a little bit of traffic over there and see if you get any warning bells, right? Or you can do a red, blue, or red, green, blue, green, red. I don't know, all the colors are mixing together lately. But you can use this to your advantage for adds, moves, changes, and anything that you have planned. Remember, if it's unplanned, the global accelerator is going to do this for you. And then the last thing, of course, I wanted to mention on this part of the traffic control is client affinity. So there are some applications out there that require, when someone starts to communicate with one of your target endpoints, that the rest of the flows and the communications need to keep going to those endpoints. For that, you would choose affinity, and affinity is a 2-tuple base, right? Source IP, destination IP is how we're going to handle that. So can anybody guess how long, when you make these traffic changes, it takes to propagate worldwide? Any guesses? Seconds. Okay, that's kind of a cheap guess, but I'll give it to you, 30 seconds. You get a prize. I don't know what it is, but you get one. Yes, every one of your changes will actually propagate around the globe within 30 seconds. And again, Harvo can show you the magic of why that is. And speaking of that, I'm going to pass the baton over to Harvo Jones.
Great, thank you. All right, we can keep the ball rolling. Let's cover some of the security, availability, and performance benefits that are at your disposal when you're using Global Accelerator. So the very first of those, security, it starts with this Amazon Global Network, just as James already mentioned. Between any of these links, between Amazon facilities, these links that traverse the ocean, every one of those is protected by AES 256 link level encryption. And this is on top of whatever encryption you're already running for your own applications, such as TLS. So in addition to this network level encryption, what else is at your disposal? Well, you have security groups within your VPCs. These are stateful firewalls where you can configure which networks to restrict access to. In addition to those security groups, you have web application firewall on ALB. So with WAF, you can configure rate-based rules based on given source addresses, given sets of clients. You can protect yourselves from cross-site scripting or SQL injection attacks, and all of these with real-time visibility. So in addition to WAF and security groups, what else do you have? Well, you have what James also mentioned, which are internal EC2 instances and internal ALBs, meaning if you wish, you can spin up your infrastructure within a VPC with no public addresses at all, and then place a global accelerator on top of that, which means the only way an actor on the internet would be able to reach into your resources is if they're connecting through the listener ports that are configured on your global accelerator. And they're allowed through the WAF rules you've configured on your ALB, and if they're allowed through the security group rules that you've configured in your VPC. So this is some of the power at your disposal on the security side when you're using Global Accelerator. Now on the availability side, availability also starts with that Amazon Global Network, again. So as James mentioned, there are fewer intervening networks when you're using Global Accelerator. We push our edge locations to be as close to your clients as possible to ingest this traffic onto our backbone, our constantly monitored backbone. And we, as AWS operators, we want to make sure we're giving you the best service that we can give you. So we're constantly monitoring our own service from given geographic locations, monitoring them over the open internet, reaching toward an AWS region, and doing those same tests through Global Accelerator to make sure we're offering the service that we can. And at times, we do see disruptions over the open internet where we don't see those disruptions over this monitored Amazon backbone. Sometimes those disruptions that we see over between these intervening networks, they may be cyclical. There may be a daily pattern of events that a given network is experiencing that leads to these patterns of congestion or packet loss, whereas we're constantly monitoring and adjusting our own network to make sure we're handling these events properly. So that's just on the Amazon network itself, but availability is actually built in to our service from the foundation. And that's the case with every service that AWS offers. So let's go through a couple of scenarios. So what we have is we have these edge locations, these facilities where we've deployed our own infrastructure out at the edge. From these edge locations, we're using Border Gateway Protocol, BGP, to announce our IP prefixes out to the internet. We have peering connections, we have links with transit providers, and we're announcing our own IP ranges, saying, hey provider, if you see a packet on the wire destined for an address within this prefix, go ahead and send it my way. And then a couple cities over, we'll have another edge location announcing the same routes out to the internet. If you see a packet on the wire destined for an address within this prefix, send it my way. Everyone's saying that. So what kinds of disruptions can happen in this case? If there are a given set of clients that are actually actively leveraging one of these edge locations, what if there were a network misconfiguration that affected a given specific IP address or an entire block of IP addresses? All of our customers that may be attempting to use that block of IP addresses may be unable to use that edge location if that were to happen. That could be a misconfiguration, it could be a power event, or what have you. What other kinds of problems can occur? There are also heavy workloads Workloads from our own customers can be so heavy that they may disrupt the service that other customers experience through our service, meaning a single customer being a noisy neighbor can cause disruption across the board. So how do we address these kinds of things? What we do is we break down the problem, we isolate workloads, and we reduce blast radius. So in this case, what we offer are network zones. These are similar in concept to availability zones within AWS regions. So with network zones, we take that infrastructure that we're deploying at the edge, we actually deploy isolated, independent infrastructure, unrelated to each other. We'll announce out to the internet using BGP separate IP blocks, using non-contiguous prefixes, meaning that they're not back-to-back. So with these separate network zones, when you sign up for Global Accelerator, there are a pair of IP addresses that are allocated to you. That pair of IP addresses, each of those, is backed by one of these network zones. So if we go back to our prior scenario, let's say there's a network misconfiguration or a power event, and a given ISP is not able to route toward a given one of those network zones. Well, both of those IP addresses, hand them out to your clients every time. If one of those addresses is unavailable, your clients are free to retry on the other. And we have an entire separate network zone that's ready and willing to take your traffic. So apart from that redundancy, what do we do about the noisy neighbor scenario? Well, so what we do is we take our network zones and we divvy them up into cells. And each of our customers will serve them from one of these cells per network zone. And we'll also do our part to reduce the overlap between different customers on the same pair of cells in each network zone. So by reducing that overlap, the chance is that if there were a noisy neighbor who affects both of their own cells in each of those network zones, they may not affect both of yours, or at least you may still have a healthy cell in one of the other network zones. Yeah, I always get dry mouth. So, right. But it doesn't stop there. What we do is we dig into these cells even further. So we look at the servers within each of these cells. We look at the network interface cards across each server. Each of our customers that are being served by the cell will actually serve one of them from a percentage of the hardware within that cell. And then the next customer will serve them from a similar percentage, but from an overlapping amount. The next customer will similarly overlap with the remaining interface cards and servers within that cell. So even if there's a disruption within a cell, you still have capacity available to you. So we kind of, this shuffle sharding approach, we're tackling it at 3 different levels here, with network zones, with cells, and the way that we divvy up our resources within each cell. And if we think about those first two, the network zones and the cells, the amount of, I guess, the blast radius width of a given heavy workload, the math behind it is 1 over the number of cells per zone to the power of the number of zones. So if you want to work it out, if you're thinking about deploying your own availability strategy with your own applications, you can sort of do that math to figure out what's the blast radius that I want to constrain a given customer's workload to. And that would help you work out, how many cells would I need in this sort of scenario? In this example, you could potentially go as low as 0.02%, but again, this is just using those first 2 strategies, the network zones and the cells. It's not even taking into account the overlapping strategy within each cell. Okay, so what else is available to us on the availability side within Global Accelerator? We have AWS Shield. By default, everyone is protected from AWS Shield at the edge. So what this means is when there's malicious traffic, an IP flood, a TCP SYN flood, a DNS reflection attack, your infrastructure, your resources within AWS are protected from AWS Shield dropping this traffic out at the edge. This is included with Shield Standard and with Shield Advanced. We also have availability across failures. So you heard about those knobs where available to you, you're able to shift traffic between AWS regions or across endpoints within a given region. That traffic is also shifted automatically in response to the health checks that James was describing. When we receive a signal that one of your EC2 instances or one of your ALBs is unhealthy, we'll go ahead and shift traffic. We'll route new connections around that unhealthy endpoint. And we'll do so with new connections, meaning that we're not severing existing connections. Even when we route traffic away in response to health check failures, we're doing that in a manner to maintain your availability as much as possible for your TCP connections, for your UDP connections. And let's see what else. Right, so this goes even further. Not only do we have this availability strategy for your own traffic, one of these edge locations that I was mentioning, we could have a problem. And one of them could fall off the network altogether. What happens is those BGP announcements that I was mentioning, we use those internally as well. And that BGP convergence within our own network completes within seconds, meaning if one of these entire edge locations goes offline, a sibling edge location in the same network zone announcing the same IP prefixes would begin taking that traffic within a couple of seconds. Or going even further, zooming into our infrastructure, if one of our servers were to fully fall offline, we'll just route around that internally within our own system. And there's a feature, there's a checkbox when you go ahead and sign up for Global Accelerator. It's called Client IP Address Preservation. When you turn that on, that means your services, your EC2 instances and ALBs, they see traffic arriving to them from the clients that are connecting to you. And what that means is when you turn that on, and we're routing around our own infrastructure internally, your services don't even realize we're routing around our own infrastructure because they just see those client addresses. And this is a little depiction for what I was just mentioning. You can use Global Accelerator in NAT mode, meaning Network Address Translation. We'll take the IP packets from your clients, and we'll translate them so that the source address is one of our Global Accelerator own source addresses. That's one mode in which you can use your Global Accelerator in. The other mode with client IP address preservation, we'll take those client packets and we'll encapsulate them. We'll throw a little metadata header on top of that IP packet. We'll go ahead and use a transport layer and use our own IP addressing layer. We'll take that full encapsulated packet with your original client packet wrapped up right down there in the middle, and we'll route that all the way toward the AWS region, where we'll unpackage it and deliver the original internal packet to your endpoint. And so you see what that means. The original client source address preserved all the way down there means that we don't have to modify that address to route around our own infrastructure. Yeah. And there's a thing on the internet called the maximum transmission unit, which is the largest size a packet can reach between two given endpoints. And it's typically 1,500 bytes. When we're doing this encapsulation, we're not detracting from your 1,500 bytes. You still get the full availability of that amount of that packet size. So you get the performance that you deserve through Global Accelerator. Yeah. And so we're preserving these addresses, and you can use these with, as I mentioned before, your web application firewall rules, your security group rules, your own logging. When you have endpoints behind ALB, ALB will supply to your services that X forwarded for header. That's the client IP address going all the way through. All right. So we can't talk about Global Accelerator without mentioning performance. And again, a repeating theme, it all starts with the backbone. This is a really impressive network. So let's say you're running your service from US East 1, just as James was mentioning, we have our own edge locations pushed out as close to your clients as possible. So as soon as possible, those connections are ingested right onto our network and then routed toward US East 1 over our backbone. And you'll see performance improvements. So the way that we measure performance, we think of it in terms of time to first byte, also known as latency. Another way to measure performance is throughput. And another way is jitter. As low of of an amount of jitter as possible, meaning a consistent experience. And so you'll see time to first byte, this latency, varying per client location and per AWS region. Similar examples, if you're running an AP Southeast one, you'll have different measurements of performance improvements that you're able to see. And so I often think of, there are two ways to really deploy your services behind Global Accelerator and experience this improvement. The first way is what's shown over here in that single region mode. So you really are leveraging the AWS Backbone itself. The second way is in dual region mode. So in dual region, you kind of get that double whammy. Not only are you leveraging the performance improvements of the network, but your clients are being routed to a closer AWS region anyway. So of course, that's going to be more performant. And in addition, with the dual region mode, you get the benefit of having this failover protection. If services in one location become unavailable, then all new connections get routed to whichever region you still have available. All right, building with Global Accelerator. So this part's pretty straightforward. A lot of us are familiar with builder tools. By that I mean tools you may be using within your own companies to develop applications. Here I'm just using some examples that AWS offers, but this is usable with any tools that you wish. So I myself have gone through and built a to-do application. It was a fun thing to do, and I use it on weekends to work out with my kids and my wife what we're going to do that weekend. And so you might want to start with a front end. So here's a little bit of HTML. You see a little title, little to-do title. A couple of lists. What do I want to do today, tomorrow? You might have a backlog. You might also have a backend. A backend, this one here is written in Go. It's using the DynamoDB SDK and writing some task items into a table. And all of this you can compile using code commit. Once you compile that with code commit, you submit it with code commit, you build it with code build, right? Then you can leverage code deploy. What would code deploy do? It would package this all up, get it delivered to one of your instances, spun up as an application. Simple enough. You can then use code pipeline. Do that same code deployment in another region and another region across the world. You nearly have a global application. What do you do next? You throw a Global Accelerator on top of it. So now we have a simplistic, global, multi-region application. There's one thing missing. With global applications, I often think of how do you actually manage state? And the few ways that I've thought of managing state, you might have a stateless application, or it doesn't matter. You might be done right here. Sometimes you might have state that's specific to clients in a given region. So you just use something local to each region. Or the third case is you might need a globally distributed state. So in that case, with globally distributed state, there are multiple things at your disposal, multiple options. DynamoDB Global Tables is one example. You can use Aurora Global Database. You can use objects in S3 with cross-region replication. So in this example is pretty simplistic to use DynamoDB, and that was it. That's how I built this multi-region application. And this coming Saturday on our list is morning kayak, hitting up the roller rink, then bonfire in the evening. That sounds like a good day. All right, examples. Who actually uses Global Accelerator? What do they really use it for, right? The trade desk. Trade desk is a major one of our customers. Skyscanner, New Relic. Some of these use cases are HTTP use cases. Some of these are non-HTTP use cases. On the HTTP side, you have those blue-green deployments where you want to dial traffic to one set of instances, deploy something, test it out, then dial traffic back up. Might be performance reasons. You might want to load balance across a large number of HTTP servers. On the non-HTTP side, you might have a UDP application where you're running a gaming between multiplayer clients. It might be a voice over IP application. Might be messaging, such as MQTT. So there are multiple applications here for using this service. Here's one example from Skyscanner. They're using Global Accelerator for their distributed DNS fleet. And you can see in their quote there, Global Accelerator enables us to effortlessly build resilient, multi-region services, allowing us to focus on providing our travelers with the best experience possible. See, it lets them focus on their core business. And we're helping them take care of the network and the performance for them. IP whitelisting, API acceleration. So with Paar, they offer points of sale. And these points of sale in multiple locations are all calling back into their services, their ALB. And they're using Global Accelerator. And you can see right there in the code, it allows them to leverage the high availability and low latency of Global Accelerator. What else do we have? We have live video ingest with Flow Player. Allows them to improve performance and availability of video ingest for users around the world. I think that's a really cool use case. Let's see so this one with Crazy Call, so an online call service that they offer. They're using Global Accelerator to help stitch these calls together. One thing that I found interesting is when they deployed Global Accelerator, they saw a reduction in the number of support calls of users complaining about call quality and disconnections. So not only were they able to leverage the performance, but that availability translated to this improved experience for their service, for their customers. And there's one more example we can go over. What if you're a gaming customer? You want to offer this sort of multiplayer option where one strategy would be, okay, you as player one and you as player two, I want you to both connect to this Global Accelerator IP address, however, connect with a destination port of 1234. Right? There are 65,000 ports available to us, and you can configure any of them for use on Global Accelerator. So you can divvy up different ports for different gaming sessions and start handing out those different ports to your users. Yeah, and so whether it's streaming video or streaming audio, whether it's a chat application or gaming application, might be customer service or some sort of IoT application, there are multiple workloads that make sense with Global Accelerator. And it's really an honor to help all these various businesses meet their needs. And yeah, this is the end for me. This is my last slide is just recapping what James actually opened with, the key features of the service. There are a pair of IP addresses, which are your global entryway into this Amazon global network. And just to harp on that a little bit more, what we've taken this global network, and we've packaged it up into a service that you can use. So there's a ton of power there. We offer this routing for TCP and UDP, load balancing across the world. You can target EC2 instances and ALBs, which are private without any public addresses. We also support network load balancers. And you can use this to accelerate your single region workload or your multi-region workload. And all of this with this inherent DDoS protection and the availability of the backbone. That's it. Those are the key features of Global Accelerator.
Thank you.